In this video, we're going to be going over the 2025 National 5 Physics Section 2 paper. And before we start, make sure you like and subscribe, and make sure you check out my Head Start to Higher tutoring on my TikTok at National 5 Physics. So question 1 says, a gardener is mowing grass with a lawnmower and the garden walks from point X to Y as shown. By scale diagram or otherwise, determine the magnitude of the resultant displacement of the gardener from point X to point Y. So it says by scale diagram or otherwise. I'm going to do the calculation method because I think it's a better method for me. So the way to do this is uh, the gardener moves 32 meters straight and then 15 meters left and then 4 meters straight. Now you can see that this is the same as going 32 meters straight and then 4 meters straight and then going left as well. So what I'm going to do is I'm going to do a total distance I walk straight and then the total distance he walks left. So I'm going to draw a triangle. So I'm going to put this here. I'm going to put an arrow to mark my vector, and I'm going to make this 36 meters as this is the total distance he's traveled straight. And then we're going to go left 15 meters and then 15 meters, and then we're going to put a resultant vector from the start to this. So this is point X here and this is point Y. And then we put a resultant vector with two arrows indicating that this is the displacement. And then this is right angles here. This is your angle. And this is, well, here is asked for the displacement. So just the displacement, the magnitude of the displacement. So we can just get the size basically. We don't need the direction. I'm going to say that side is c. So using Pythagoras theorem, I'm going to do c squared equals a squared plus b squared. And that's going to be 15 squared plus 36 squared is c squared. And then c is equal to the square root of 15 squared plus 36 squared. And c is equal to, if I put that into my calculator, 15 squared plus 36 squared, that's 39 meters for the displacement. So I'm going to double underline that, and that's question A, part 1. 1a part 2 says by scale diagram or otherwise determine the direction of the resultant displacement of the gardener from point X to point Y. So here we need the direction, and you can see here we have to turn X amount of degrees to face Y and then walk forward across it. So we need to work out this angle in here. So here, I'm just going to do the working here. So here we're going to use trigonometry to find out this angle in here. So first we need to identify the sides that we have. So I'm going to redraw this triangle this way up to make it a little bit easier to see which sides we have. So there's the angle, and here's our other angle. Sorry, this is the right angle, and this is our resultant. So you can see that we're given the adjacent here. This is the adjacent, and this is the opposite angle. So I'm going to do tan theta because we have the opposite and adjacent, and it's TOA, TOA. So is opposite over adjacent, and that's going to be 15 over 36 is tan theta. So I'll move this up here. So theta is the inverse of tan 15 over 36. So theta gives us 22.619. I'm going to round it up to 23 degrees here. But we are not done yet because if you see here, I'm going to use a bearing, and we measure bearings from the north line, and you can see that to get this angle here, we need to turn all the way here. So technically it's actually this bearing over here. So it'd be 360 minus 23 for our bearing. So I'm going to scroll down here. I'm going to do 360 minus 23, and that gives me 337. So I'm going to write the bearing as 337. 337. $1. Part B says the gardener takes 55 seconds to walk from point X to point Y. Determine the average velocity of the gardener from point X to point Y. So you should know that velocity is just the displacement over time. And we just worked out the displacement to be 39 meters. So it'd be 39 over 55 for the time, and that gives us a velocity of 0.71 meters per second. I'm going to run that. And we're not done yet though, because velocity is a vector, so it must have a direction. So we can use the bearing that we just calculated in the last question. So I'm going to write at a bearing of 337. Double underline. That's me done part B. Now part C says the gardener pushes a lawnmower with an average force of 68 newtons while walking between point X and point Y. Calculate the work done in moving the lawnmower between point X and point Y. So we should know that the formula is EW equals FD, and the force is 68 newtons. And you see here that we need the distance. Now if you look up here, we need the work done in moving the lawnmower between point X and point Y. Now let's go back to the diagram. This is point X and this is point Y. So we need to calculate the total distance. So 32 plus 15 is 47. 47 plus 4 is 51. So here we use the distance of 51. So EW works out to be 3,470 joules. I rounded up to 3 significant figures. That's it. Question 2 says the Falcon Heavy rocket is used to carry a satellite from Earth into space. The total mass of the rocket and satellite at launch is 1.43 times 10 to the 6 kg. Calculate the weight of the rocket and satellite at launch. So here we use W equals mg, which is 1.43 times 10 to the 6 times the gravitational field strength, which is 9.8, and that equals 1.4 times 10 to the 7 newtons for the weight, and that's done. Part 2 says, at launch, the initial upward thrust acting on the rocket is 2.28 times 10 to the 7 newtons. Determine the initial acceleration of the rocket and the satellite. So before I start, I'm immediately going to notice that this is 4 marks. And a little tip is when you have a 4-mark question, it means you need to do a little something extra, maybe like a small calculation at the side. So here I'm going to work out the initial acceleration, and I can only get the initial acceleration if I have the unbalanced force, since the formula is F equals ma, but I like to remind myself that's an unbalanced force by doing fun equals ma, F unbalanced force. So the unbalanced force is the force when the force is bigger in one direction. And here we need to find that. So I'm going to write fun is equal to, well, what am I given? I'm given the initial upward thrust. So the thrust force, which is acting up, minus the weight. The weight is acting down. Because if you see, if I draw a free body diagram, here's the thrust, and here's the weight. The weight is acting against the thrust. So in order to have an unbalanced force, the thrust force must be bigger than the weight. So it's going to be thrust minus weight, which is 2.28 times 10 to the 7 minus 1.4 times 10 to the 7, which we just worked out. And that gives me an unbalanced force of 8.8 times 10 to the 6 newtons. Now I can do fun equals ma, which is the mass, which is 1.43 times 10 to the 6 times A is equal to 8.8 times 10 to the 6. So A is equal to 8.8 times 10 to the 6 all over 1.43 times 10 to the 6. So A is equal to 6.2 meters to the minus 2. Question 2b says the rocket is designed so that many parts are reusable. 2 reusable parts are the payload fairing sections, which protect the satellite during launch. Once the rocket reaches space, the payload fairing sections are detached and re-enter the Earth's atmosphere. On the diagram below, show all the forces acting on one of the payload fairing sections as it falls vertically through the Earth's atmosphere. You must name these forces and show their directions. So when you're close to a planet or body, you have a weight, and this weight causes you to fall because it's the force of gravity acting on you. So down the way should be your weight because this is what's making you fall down. The other force that acts against you is air resistance because when you fall, the force of friction is opposing your motion, and this is in the form of air resistance, is pushing against you. So the only forces acting on this is weight and air resistance. Question 2BII says, at one point, as it falls through the atmosphere, the parachute attached to the payload fairing section is opened. This causes the speed of the payload fairing section to decrease rapidly. Explain, in terms of forces, how the parachute reduces the speed of the payload fairing section. So what I've written for this is the parachute causes the air resistance to increase. The air resistance is now greater than the weight, causing an unbalanced force to act upwards. This causes the payload to decelerate, i.e. slow down. Part 3 says the graph shows how the vertical velocity (vv) of one of the payload fairing sections varies with time t from the moment the parachute is opened. The weight of the payload fairing section is 9,300 newtons. State the magnitude of the total upward force acting on the payload fairing section at point P. So from the graph you can see that the vertical velocity is decreasing, it's a curve, and then at point P it's a straight line. This means that the forces are balanced as there is a constant speed of the payload fairing. So I've written, at point P, the object is traveling at a constant speed. Therefore, the forces are balanced, so upward force is 9,300 newtons. So question 3 says, ski jumping is a winter sport in which competitors aim to achieve the longest jump after sliding down a specially designed curved ramp. During the jump, ski jumpers adopt the position below. The length of the jump is measured from the end of the ramp to where the ski jumper lands. Using your knowledge of physics, comment on the factors that affect the length of a jump made by a ski jumper. So these are a couple of topics you could talk about, but these are not all of them. This list is not exhaustive, so maybe if you have something else, it could be right. As long as you explain it well, then you'll get the marks. So I'm going to explain this one, takeoff speed. So imagine you have a ski jumper moving at 1 meters per second, and since d is equal to vt, the time is the same, and this is 1. Let's assume the time is 2 seconds in the air. Then the distance traveled will be 2 meters. And now if you have a ski jumper traveling at 10 meters per second when they go down this ramp, since d equals v over t, sorry, d equals vt, if this is 10 and this is 2, because acceleration due to gravity is the same for all objects, so these two ski jumpers will be in the air for the same amount of time. The distance here traveled will be 20 meters. So obviously the takeoff speed will affect the length of the jump made by a ski jumper. The second point here, aerodynamic clothing. This will affect the ski jumper because if this jumper is wearing baggy, loose clothing, this will cause air resistance in this direction to increase. So therefore, aerodynamic clothing will affect the length of a jump made by a ski jumper. So if you explain the physics behind everything that you wrote down, you should be getting 2 to 3 marks. Question 4 says, in 2023, a spacecraft was launched from Earth to investigate the asteroid Psyche. Psyche is located in the asteroid belt between Mars and Jupiter. The spacecraft will reach Psyche in 2029. A says, on its journey to Psyche, the spacecraft will pass close by the planet Mars. Explain how passing close to Mars will reduce the journey time to Psyche. So I've written, it received a gravitational boost / slingshot from Psyche, causing an increase in its speed. This is something they should know from learning the theory in space topic. Question B says, on its journey, the spacecraft uses an ion drive engine to provide thrust. The ion drive engine produces a small unbalanced force on the spacecraft. Explain how the small unbalanced force can result in a large increase in speed even though the spacecraft has a large mass. So I've written, a small unbalanced force acts for a very long time. This causes the spacecraft to accelerate for a very long time, causing a large increase in speed. Question 4BII says, the ion drive engine is powered by solar cells. Near the Earth, the solar cells provide 20 kilowatts of electrical power. As the spacecraft approaches Psyche, the solar cells will only produce 2.3 kilowatts of electrical power. Explain why the solar cells produce less power as the spacecraft approaches Psyche. So I've written, as the spacecraft moves further away from the sun, less light energy reaches the solar cells. This means less electrical energy is produced per second. Question C says, when the spacecraft reaches its destination, it will go into orbit around Psyche. Initially, the spacecraft will complete 41 orbits of Psyche in 56 days. Determine the orbital period of the spacecraft. So we have 41 orbits in 56 days. So that means we have 56 over 41 orbits, and that gives me 1.365, but I'm going to write down 1.4 days for one orbit. Part 2 says after 56 days, the spacecraft will move to an orbit closer to Psyche. State the effect this change will have on the orbital period of the spacecraft. Well, the orbital period should decrease. So let's assume that this red dot in the middle is Psyche, the planet. This orbit here is the spacecraft's initial orbit, and you can see there's a big circumference. And since d equals v over t, sorry, d equals vt, then t is equal to d over v. And if you have the same speed and the distance increases, then the time will increase. Now, if you have a smaller orbit, then the circumference is obviously smaller. And if it's a smaller distance and the same speed, will take a smaller time to orbit. So this causes the orbital period to decrease. So question 5 is about a Van de Graaff generator, and we need to explain why the foil dishes are repelled from the metal dome when foil dishes are observed to fly away from the metal dome, as shown. So I've written, the dome is positively charged and the foil dishes are also positively charged, and like charges repel each other. 5b says the teacher then discharges the dome by placing a small metal sphere near the dome as shown. During the discharge, 2.5 times 10 to the negative 6 coulombs of charge is transferred to the dome in 0.8 milliseconds. We have to calculate the average current during the discharge. So we use the formula Q equals IT. Then we substitute the values. So I've got 2.5 times 10 to the negative 6 equals I times 0.8 times 10 to the negative 3. So I is equal to 2.5 times 10 to the negative 6 all over 0.8 times 10 to the negative 3. And that gives me 3.1 times 10 to the negative 3 coulombs. This is rounded. In part 2, we're asked the magnitude of the charge on an electron is 1.6 times 10 to the negative 19 coulombs, and we need to determine the number of electrons transferred during the discharge process. So to do this, we have the total charge, which is 2.5 times 10 to the negative 6, all over the charge on one electron, which is 1.6 times 10 to the negative 19, and this will tell us the total amount of electrons that we have. And I'm going to round it to 1.6 times 10 to the 13 electrons. So question 6, we're asked to complete the circuit diagram to show how components will be connected, and we have these to use, these circuit components. So we need to measure the voltage across the resistor R and the current in resistor R. So you should know that ammeters are always connected in series, and this will measure the current in resistor R since the current is the same area. And to get the voltage across R, we connect a voltmeter across R, and this will give us our answer. So question 6b says the student obtains a range of readings for the current in and the voltage across resistor R. And then they draw a graph, and we have to use the gradient of the graph to determine the resistance of resistor R. So the gradient is the resistance of R. So what we do is we do M equals y2 minus y1 over x2 minus x1. And then we pick 2 points from the graph. So I've picked these 2 points here. And it's good to pick points that are further away from each other. So it reduces the likelihood of errors and gives you a more accurate answer. So I'm going to do 4.2 minus 0.2 and 0.071 minus 0. And that gives me a gradient of 56.3, but I'll round it to 56 ohms. So 6c says the student now replaces resistor R with a filament lamp and repeats the investigation. A sketch graph of the student's results is shown. State the conclusion that can be made about the resistance of the filament lamp. So you can see that the resistance is not constant. As you can see, the line is increasing, it's getting steeper upwards, and this means that the resistance increases as the current in the lamp increases, and therefore the resistance is not constant. So question 7 says, at night, a path is illuminated by a set of 4 LED spotlights. Each spotlight consists of an LED and a resistor connected in series. The circuit diagram is shown. Describe one advantage of connecting the spotlights as shown in the circuit diagram. And I've written, if one LED breaks, the other LEDs will stay on because this circuit is in parallel. So if one branch is broken, then the other branches will stay lit as current can still pass through these branches. So question B says each spotlight has a power rating of 4.8 watts. Determine the total current drawn from the power supply when all 4 spotlights are operating correctly. So we can do P equals IV, and then do I equals P over V for the current. So I is equal to, now we substitute the values in. Now the power rating for one spotlight is 4.8, and we have four spotlights, so we do times by 4, all over 12, because in the circuit above the voltage is 12, and this gives us a current of 1.6 amps. So 7C says the spotlight circuit is connected to the circuit shown below so that the spotlights switch on automatically when it gets dark. I says to state the name of component X, and this is called a MOSFET. So part 2 says we have to explain how the circuit operates to activate the relay when it gets dark. So this circuit question is quite common in exams, and just to make it easier, I provided the marking scheme, what it should look like. So you get a mark for saying the voltage across the LDR increases, because as we know, I have an acronym called LIRD, which is light up, resistance down. So the inverse must happen when it gets dark, which is light down, resistance up. And this causes the resistance of this to increase and therefore the voltage across it to increase. And this causes the MOSFET to turn on here. And then this closes the relay switch and activates this circuit over here. So there's how you get your 3 marks. So question 8 says a student is describing how the following circuit works. The student states, when I connect the battery to the lamp, electrons are fired from the battery and whiz around the circuit. The electrons are changed into light by the lamp. If I add another lamp to the circuit, the lamps will be dimmer. Using your knowledge of physics, comment on the statement made by a student. So from what I can see, I can only see 2 things which I could talk about. First, I could talk about the incorrect statement that how the electrons are changed into light by lamp. This is incorrect as electrons carry energy from the battery to the lamp. They do not change. Will always be there. They're just carrying the energy and supply the energy, electrical energy to the lamp to change this electrical energy into light energy. The other thing that I could talk about is if I add another lamp to the circuit, the lamps will be dimmer. Well, this depends on how you add the lamp, because if you add the lamp in series, well, right next to each other, then the lamps will be dimmer because the voltage across each lamp will decrease as in a series circuit, voltage splits across the lamps. Now, if I add a lamp in parallel, the voltage of the lamps will be the same, and therefore the lamps will be the same brightness. So these are 2 things that I think you could talk about. Obviously, this is not an exhaustive list. As long as you qualify your answer, you should get the marks. Question 9 is about an ice making machine, and A says the ice making machine is initially filled with a 0.3 kg of water at a temperature of 22 degrees Celsius, and we need to calculate the amount of energy removed from the water to reduce the temperature of the water to 0 degrees Celsius. So the formula we use is EH equals Cm delta T, and we use the specific heat capacity of water, which is 4,180 times the mass, which is 0.38 kilograms. And the change in temperature is we're going from 22 degrees Celsius initially to 0. So that's a change of 22 degrees Celsius. And that gives us an energy of 3.5 times 10 to the 4 joules. Next, we're told the ice making machine has a power rating of 120 watts, and we have to calculate the minimum time it takes to reduce the temperature of the water to 0 degrees Celsius. So here we're given the power, which is 120 watts. We need to work out the time taken, so T is unknown. And the only thing missing from this equation is E, the energy, which we just calculated up here, which is 3.5 times 10 to the 4 joules. Now we can do P equals E over T. And then we can do 120 equals 3.5 times 10 to the 4 all over T. So that means T is 3.5 times 10 to the 4 all over 120. So T is equal to 290 seconds. 9a part 3 says, in practice, the time taken to reduce the temperature of the water to 0 degrees Celsius is much greater than calculated in AII due to heat gains from the surroundings. suggests one way the manufacturer could improve the ice making machine to overcome this problem. So if we're having heat gain from the surroundings, then heat is getting into the machine. So therefore, to reduce this, we can insulate the machine to keep this heat energy out and therefore reduce the time taken. So part B says once the water is at 0 degrees Celsius, a further 15.3 kilojoules of energy is removed from the water to form ice cubes. Calculate the maximum mass of ice cubes produced in the process. So here we use the formula EH equals ml. And be careful for which L value you use because here we are changing from liquid to solid. So we use specific latent heat of fusion of materials. And this for water is equal to m times 3.34 times 10 to the 5. And the energy removed is 15.3 times 10 to the 3. So to rearrange that for m, we do 15.3 times 10 to the 3 all over 3.34 times 10 to the 5. And that gives us an answer of 0.046 kilograms rounded. And there's our answer. So 10 says we have to describe how the kinetic model accounts for the pressure of the air in the syringe. So I've written the particles collide with the walls of the syringe, and that's our answer. So for 10b, you had to plot a graph, and this is the graph I plotted. Every graph will be different, so don't worry if your graph does not look quite like this. Just make sure you have the axes labeled with this label here and this label here. And then you had to determine the relationship, and I said P is directly proportional to 1 over V, since my graph goes to the origin. And then you had to use your graph to determine the volume of trapped air at pressure 148 kilopascals. So you find 148 kilopascals, which is marked by this purple dot over here, and that coordinates to 0.225. So if you take the inverse of that, that becomes 4.4 ml. And one way the experimental procedure could be improved is to repeat the measurements and calculate an average, or you could say increase the ranges of volumes used. So in question 11a, we need to state what is meant by the term transverse wave. And transverse waves are when the vibrations are 90 degrees to the direction in which the wave is traveling. So for BI, we need to show the frequency is 0.28 Hertz. So we use the formula F equals number of waves over time. And there are 500 waves in 30 minutes. So we do 500 all over. Now remember, we use seconds, so it's 30 times 60 to get the number of seconds. And that gives us a frequency of 0.277. And the simplest to show that question, I'd show this first and then round up to 0.28 hertz. B part 2 says each wave takes 32 seconds to travel the length of the pool, and we need to calculate the average speed of the waves. So the length of the pool shown here is 160 meters. So we use the formula V is equal to D over T, where D is 160, which is the length of the pool, and it takes 32 seconds. So V is equal to 160 divided by 32, which is 5 meters per second. Part 3 says to calculate the average wavelength of the waves. So we use the formula V equals F lambda. So and we rearrange this to lambda is equal to V over F. And we use the speed that I just calculated, which is 5. And the frequency was 0.28 of the waves. So lambda is equal to 5 divided by 0.28, which is equal to 17.9 meters. In question 12AI, we need to show that the time taken for a microwave signal to travel from the satellite to the GPS device is 0.067 seconds. So we do T is equal to D over V, where D is the distance to the satellite, which is 20,200 kilometers. So that's 20,200 times 10 to the 3. V is the speed of a microwave signal, which is 3 times 10 to the 8, since it's an electromagnetic wave. So that gives us a time of 0.007 6, 7, 3, 3, and on and on. So I'm going to round that to 0.067 seconds. So for part two, we need to state whether the GPS satellites are geostationary satellites. I've said no because the period of geostationary satellites are 24 hours to ensure they stay in the same position when orbiting Earth, whereas the GPS satellites have a period of 12 hours, which is shown here. As long as you say something similar like this, then you should get the answer correct. Also, you could say that the altitude of a geostationary satellite is 36,000 kilometers, whereas this one is 20,000 kilometers. So in 12b part 1, you state a suitable detector for infrared radiation, and this could be a photodiode or a phototransistor. This list is not exhaustive, so when the marking scheme comes out, there may be multiple answers. So part 3 says to determine the distance of the target from the golfer. And before I start this question, I immediately realized that this is a 4-mark question. So the 4-mark question means you need to do another calculation before you do the main calculation to get the answer. So the clue here is the time taken between the infrared radiation being emitted and received by the rangefinder is this time. So for it to be emitted, so let's say this is the rangefinder and this is the distance. It's for it to be emitted, so go all the way here, and then received, so go all the way back, is 1.2 times 10 to the negative 6 seconds. So for one way, it'd just be half that time. So I'm going to write t is equal to 1.2 times 10 to the negative 6 divided by 2, which is equal to 6 times 10 to the negative 7 seconds. And now we can find the distance. So we do d is equal to vt, where v is the speed of light since it's an infrared radiation, and t is 6 times 10 to the negative 7 seconds. So this is equal to 180 meters. 180 meters. So 13 part A says to state the names given to angles x and angles y. So you can see that the light is going this way since due to the arrow, and it's going in here. So angle x is the angle of incidence, and then you can see that angle y is smaller than angle x, and this means that angle y is the angle of refraction. So for part B, we have to explain why the ray of red light changes direction as it enters the circular glass block. So I've written the light is going from a less dense medium to a more dense medium as it's going from air to glass, and is traveling at an angle to the normal, which you can see here. This causes the light to slow down and bend closer to the normal, which is displayed in the diagram. So for 13C, we need to complete the diagram below to show the path of the ray of red light after it exits the block. So here we're going from glass to air, so we're going from more dense to less dense, and therefore the light should move away from the normal. So make sure you really make that clear in your picture, have the angle of refraction greater than the angle of incidence. So for 14A, we need to explain why a tracer that emits gamma radiation is used for this investigation rather than one that only emits alpha or beta radiation. So I've written alpha and beta radiation would not be able to penetrate through all the layers as alpha and beta radiation are easily absorbed by these thick layers over here, whereas gamma radiation would be able to and reach the radiation detector up here. So for B part 1, we have to state what is meant by the term half-life, and I've written the time taken for the activity of a radioactive source to decrease by half. So for part two, we need to state which of these radioactive sources should be used for this investigation, and you must justify your answer. So I've written barium-133 as it emits gamma radiation, so it will be able to reach the detector, and it has the longest half-life. The reason why it needs a long half-life is because if it kept on decreasing, then we'd have to keep replacing the source every short period of time. So next, we have a graph of how the activity of a different source varies with time, and we need to use information from the graph to determine the half-life of this radioactive source. So there's an easy way to take this approach. So what you do is you find the initial activity, which is 1,240 kilobecquerels, and then you divide that by 2, which is 620 kilobecquerels. Now you look on the curve and find where 620 kilobecquerels is, which is about here, and then you draw a straight line down to the time axis, and you can see that that's in the middle of 100 and 200, which is 150 seconds. Now, to double check your answer, you can half this value of 620, which is 310, find that on the curve, and then see that is exactly at 300, and we're starting at 150. So again, the half-life is 150. So the half-life of this radioactive source is 150 seconds. So C part two, we need to predict the activity of the source at 700 seconds. So to do this, I would just extend the line following this shape at 700 seconds. And you can see that this activity should be about 60 kilobecquerels. So the answer is 60 kilobecquerels. So A part 1 of question 15 says we have to calculate the absorbed dose received by the passenger here. So since we're given the equivalent dose and we're also given the type of radiation we're exposed to, we can use the formula H equals dWr, where WR is the weighting factor, D is the absorbed dose, and H is the equivalent dose. So we can write 0.25 times 10 to the negative 6 is equal to D times the weighting factor for X-rays is 1, so we can just do times 1. So D is just equal to 0.25 times 10 to the negative 6. And remember the units, which is grays. Next, we need to calculate the energy absorbed by the passenger. So since we have the absorbed dose and the mass, we can do this by using the formula D is equal to E over M. So E is equal to dm. Now that's 0.25 times 10 to the negative 6 times the weight mass, which is 64 kilograms up here. And that gives us an energy of 1.6 times 10 to the negative 5 joules. So question B says state what is meant by the term ionization. And this is when an atom loses or gains electrons. You can have one of the two. So you can either say when an atom loses electrons or gains electrons or both. And question C says, suggest one safety precaution but the member of staff operating the scanner could take to minimize their exposure to X-rays. So I've written, shield the staff with a LED screen. This is not the only answer. There's multiple answers like limit the exposure time and so on. That's gonna be it for this video. Make sure you subscribe and like and follow my TikTok and check out my Head Start to Higher tutoring classes if you're doing higher physics or higher maths this year. Other than that, take care and I'll see you in the next video.